So now that you have your data in these columns here, we have to do some calculations. The first thing we have to do is calculate the velocity. So what we're going to do is start off with the velocity of 0, because initially the ball was not moving, it was dropped. In the next cell below it, right here, we need to write a formula. And the way we find velocity is we take the distance it has traveled and divide it by the time. So we're going to write a formula. The distance it has traveled is, I'm going to open parentheses, the position here in cell D9 minus where it was in the cell before it, D8. So that tells me how far I've gone, and I've got to divide that quantity by the time, which is B9 minus B8. So that formula there is going to calculate the velocity for me at that time. And then if you copy it down, it will continue to calculate the velocity for every interval of time until you reach the ground. So there's the velocities, and they'll continue down. You just keep copying those down. Then you're going to have to find the time. It's over here in this column. So the easy way to do that is just to type equals. So what goes in cell G8 will simply be whatever is in cell B8. So that just copies the time from one cell to the other. You're going to have to write a formula for the kinetic energy. The kinetic energy uses the mass, and it also uses the velocity, so it will use this cell here. You'll have to calculate the potential energy. Potential energy uses G and the mass and the height, and the Y position here is the height. So use that to calculate the potential energy. And then the total energy is the sum of the kinetic plus the potential. So that's how you can do the calculations. And then you're going to make a graph of these last 4 columns. The time will be on the x-axis, and the 3 energies will be on the y-axis. So that's what your graph's going to be made from. Okay?